Okay, so this is called the conditional statement, if P then Q. So if we're going to negate this, so this is what it's equivalent to. So notice there's no if then, there's no arrow, right? This arrow means if P then Q. There's no if then in the negation. So what the negation says, P and not Q. So remember, if this is true, if I show up on Monday, then I get the job. So let's make it false. I show up on Monday and I don't get the job. That's when it's false. Okay, so let's show logical equivalence with the true table, right? That's how we show logical equivalence. So again, I'm going to make up my P and my Q. So since there's just two variables, true, true, false, false, and then true, false, true, false. And then I'm going to make my conditional statement, if P then Q. So that's true, false, and these two are vacuously true. All right, so I'm just going to make my P column again here, just so it's nearby. And then I'm going to make a not Q. So false, true, false, true. So I just negated this column. So now I'm going to make a P and a not Q. So remember the and, if they both have to be true in order to get true, right? So this, hold on. Yes, both have to be true in order to be true. Okay, so this is true and false, so that's false. True and true, that's true. False and false, so that's false. False and true, so that's false. Okay, so then I need to make up the column for not P and if P then Q. So I'm taking the negation of this column. So false, true, false, false. And so I've just shown logical equivalence between these two. Okay, so now let's go and practice using this negation of an if P then Q. So here's my if P then Q, right? So if I'm going to take the negation, so this is a true statement. So remember, negation means I'm making it wrong. If it's already true, then I'm making it wrong, making it false. So the negation will be a triangle has two 45-degree angles and, right, no if then in the negation, and I'm taking the negation of this, and it is not a right triangle. So here's the statement. If a triangle has two 45-degree angles, then it is a right triangle. Yes, I know that's true. Okay, so I'm taking the negation. So I'm making a false statement. A triangle has two 45-degree angles, and it is not a right triangle. Okay, take the negation of this. If greater than 2, then x squared is greater than 4. So, okay, to take the negation, I keep the first part. X is greater than 2, and I take the negation of this, so x squared has to be not greater than 4, but less than or equal to 4. So that's the false statement. Okay, so this one I'm going to write out for you because it's got a couple of steps in it. Just want to make sure you're seeing it. So if this, then this. So take the negation. Okay, so this is if P then Q. So this is the P, and the Q has an or in it. And so I still am going to use this in general, right? But when I take the negation of this or statement, I'm going to be using De Morgan's law, right? So to take the negation of an R or S, it's not R and not S. So for this second part, right? So finally I get X is non-negative, keep the same first part, and X is not positive, and X is not 0. So not positive and not 0, couldn't I say less than 0? I could do that too, right? So X is non-negative and X is less than 0. So just making sure you see that. All right, how about this one? Take the negation of this. n is prime, then n is odd or n is 2. Okay, so to take the negation, first off I write out the first part, n is prime, prime, and I want to take the negation of this, right? So I see it's going to be De Morgan's, so I'm going to say n is not odd and n is not 2. So there's different ways of saying this, right? I could say n is even, right? And n is not 2, right? So that's the negation. Let's try another one with the combined statement. If n is divisible by 10, then n is divisible by 2, and n is divisible by 5. Okay, that's a true statement, so I'm going to write something untrue. So I'm going to take the negation. So first, n is divisible by 10, and now I'm taking the negation of this, right? So I'll have n is not divisible by 2, or n is not divisible by 5.